Here is a fixture for the dies. We have bored it, and now we are late turning out the ID before threading. Now we are threading at a couple of hundred RPMs. Okay, here is the die. You can screw it in by hand, ain't much slop. So we can maybe put us a nut on here, and this is our alignment for now. There's some more dies, they all will fit inside here. It's single weight point cut. Boys like to stick it in, so when I like to stick this in, it's too fat. I like that one too, but so for me it's just a dream. But I need to turn this down to be able to screw this section of the die in here and lock it, or I can take this one out, screw it on the other side. I don't want to do that. With no nut on, dummy test 1/10 of a millimeter, run out. This is the blank 8mm by 57 RCBS Lee, the same. Look at the overall length, and this one, it ain't going to push your primer out. So you have to gamble on something like this. If it pushes, it will be marginal. I will cut the die down. I will take the diameter a little less than the ID of the threads to be able to thread it in. So let's see. I will shorten it by 19mm, and I will take the outer diameter down to approximately 19 or something. Let's see. Fast and ugly. We let it be for now. Cleanup passes later on. The run out is 0.02 millimeters, 200 at the most, on the outside here. So we call that good for now. No, we have it in the hole. We like that. Let's see. Wiggles because it's a rough hole, and it looks good. Hole is good, and if we go in, we are fairly straight. What I'm going to do, this is the crooked, ruined die, make a sizer. I will bore the hole up to approximately 9mm, and then I will ream it. So I will get myself a straight hole. Nothing is going to follow the hole because I'm going to lathe bore myself in for the reamers. I don't follow the hole at all, but I don't want to start off with a crooked hole, you know, just because I don't like crooked holes. If this had been a straight 8mm hole, we could just run in the die reamer and call it good, turn it around, bore a little. I said hole approximately 9mm. Oh, no. Finish neck in rifle chamber is approximately 899. Here, resizing reamer, that's approximately, according to the drawing, 849 something. So I have to stay shy of that with my hole. Lathe board in here. The hole is reamed, and the first little bit is exactly the reamer neck will just start to enter. Okay, we can index off the neck. The hole is reamed inside, but it's lathe board, the very first part here. It's not that much round out. I choose to start the reamer with a live center as a support, not a floating reamer holder, because I know this is in line with that hole. So far, this is what you got. No polish, only chambering. Gauge is approximately 3.5, 3.6 millimeter out. I have to press a couple of cases, see if I need to adjust something. Moment of truth. Yes, it ain't much. You can tell by yourself. The chamber is complete, maybe not fully polished, only worked from this end, not flipped. But I may take you home, take a couple of cases to you, see if I'm satisfied or dump you. Here's the die. Now I go home for sure. You will see a little ring inside here. That is me take too aggressive a cut. Swarf get between the reamer and the die body, and shit happens. But I don't care. I was, lazy work. Here it is, almost finished. We need to thread it 7/16 by 20, and you need to buy yourself an expander assembly from an RCBS die. It isn't much to do up north on a Saturday evening, but no, it is threaded, and for fun, there is a little recess. It's when this assembly goes in. If you put an O-ring underneath here, you won't see it squeezing out. So this is 13, this is 13.5 on the recess. And we are going to have the ring buried down here if you wish to. Goodbye. Okay, no O-ring, and if we turn it around, we can see, look. It looks like it's in the middle. We are lucky, some lucky devils. Okay, with an O-ring, float a little bit, everything is okay. Bye-bye. If you adjust the die on the go gauge, here it's screwed down to touch the shoulder. With no go gauge, I'm able to screw it, if I hold the nut, approximately quarter a turn. That should be sufficient. Otherwise, you have to turn down the bottom of the die, but I think you're all set. In goes 9.3 by 62. Do 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 do. Out comes 8 by 61. Do 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 do. There is not bored a vent hole at the shoulder in the die. That has to be done, but see if it works. Maybe it works. I don't know if you can read my mic, but it says 898.5. They have sent me a standard resize reamer because that one has neck as the chamber reamer. That's the standard one. They haven't followed my suggestions, what I actually needed. So I can drop a bullet down here if I'm lucky. And I'm lucky. So I have to board your die out for interchangeable bushings, make your bushings, so you can squeeze your neck down to, let's say, 849 or something. So I have to get a new reamer, but you will be able to press cases. How far should I machine down the die and don't remove all of the neck? If I take this one, push it into the die and do like this, I get a scribe line at the start of the neck. Put this one into the die. Use the caliper, measure down here. Get this measurement. The measurement from the top of the gauge to the scribe line. Add those two and deduct for what's going to be the remaining of the neck. I shoot for 1 millimeter and hope to end on 0.5 millimeter. I'll see between there. I've set up a die, 0.03 millimeters run out. We can't do anything about that. I have to bore out the die inside for a bushing, neck bushing. And if I measure from the end, that's my reference point. We are under 0.01 millimeter, and that's what I'm looking for. Okay, we're late boring for the OD of the bushing. You're going to go 27 millimeters in for now. My target is 27.2, and I think I can torque and machine at the same time. Here is the Forster neck bump die with the bushing. We can see what kind of clearance it is. You'll probably see, but it's more than I have here. Here we can go in all the way to the bottom and it's clearance. But I may wish to have more clearance. What we have done the last cut, we went in with the cutter and worked ourselves this way to the edge and then out. So we are square here, but that doesn't matter because the buzzing is riding here, so you don't need to be square, but square is good, you know. It's good to be square. Better than to be round. Okay, we'll gamble on one more pass. Machining is done, no polish. We have to do that and thread. Now it's ready to be taken out of the jig, threaded if I wish to. I can push this inside, so I have to make the assembly, expander, buzzing itself, etc. We have to make an assembly like this for an expander like that. The bar stock is turned, lathe turned between centers. Here, flipped around like this, squared, and here we're going to have a 60-degree here, matching the live center that's coming in there, so it will be no bending whatsoever. It's threaded inside for the spindle and it's ready to be cut off. This is just a top nut for the spindle, but everything gets lathe bored. No drilling more than necessary. And I have to look at my dials and we are very close there. Okay, good. You have a straight hole ready for threading, single point threading, my friend. Here we're cutting the nut. Hope I can do two things with one hand. Off it goes. The OD is okay. The inner diameter of the neck is 0.3346 equals 849.88 something. Lathe board. The bushing is ready to be cut at 12.70 millimeters. We make it, speed it up to, wow, too much. We cut it off at 12.7. I have to do it with one hand and just do like this. In we go, in we go, in we go, in we go, and off we go. Here is the parts ready to rock and roll. This is your 3346 bushing. I made a small 23.5 shoulder per drawing if shit hits the fan, so I think it will work. Here is the die ready to rock and roll. The pin is in the middle. It rattles inside. The bushing is loose. It looks to be centered. I have to press cases. I'm satisfied for today. It's a 6-hour job today. I bored away all of the neck, so we are just in the shoulder neck junction, and on the bushing here I made a little 23.5 degree. That's the shoulder per drawing, so you can squeeze it. We'll see, we'll try it in a moment. 3346 neck with the 33.5 shoulder facing down the correct way in the die. I will flip the bushing around and see what we get. Here the bushing is flipped upside down in the die, but this is meant for be used on the fire formed cases, so first time you press it from 9.362 to 8 mil. Maybe this is not the thing, but we'll see. We fix you up with that anyways. Today, on a Sunday, I don't know if it's the 8th or the 9th of June 2013, I don't care. But today I'll try to make you a couple more bushings for the FL die with the bushing for no particular reason, and make you another seating stem for your seater die. And okay, I'll start with this one. This is a, let's say, 3346 neck. That will be the same neck as your new resize reamer when it arrives. And I have pressed cases. I've been seating bullets. And it presses it a little down. The expander opens it up to approximately 815 and the bullet is 8.2. This is just measured with a vernier cal, not with these things or that one or whatever. Here is the old try before I made the dies to find out bushing diameters, chamber diameters with odd 6 cases and 9362 cases, Norma, etc., Remington, blah blah. When you try to squeeze down 9362 that is shot in a chamber, 9362 chamber, let's say approximately 10 millimeter OD, I'd like to press it down to 8.5. You can do that in one pass, it's okay. If you try to do that and also press the shoulder down, no good. We're going to talk about that another time. So we have pressed and we know that we can press it from 10 millimeters to 8.5 and no worries. But I'm going to make you a bushing. This won't press the body down. Let's say a 9.5 or let's say a 9 millimeter bushing inside. Then you can come half the way and then I will make a bushing that's a little bit bigger. Let's say I make a bushing that's I may have to flip it. May I like a bushing with an ID of 8.6 millimeters. Then there is not that much resistance when I talk too much. When the expander goes up again, open it up. It's okay as is. It's just to kill some time. Do I have enough time? Yeah. Do I have enough to do? Yes. Why do I need to kill time? Kill time. I don't need to kill time. I'm too busy for that. But actually it starts to get summer and it's warm outside. Then I don't want to stay inside machining. That's the whole reason. So, nothing more than that. It will be a bushing approximately 23.5 degrees start on the shoulder. The other one will be square. The bushing will be marked. It ended up 9.1. First squeezing down in your die. And let's say 13 long, if we're lucky. And then we just chop it off and let it drop. And for no particular reason, you end up with a third bushing, plus the one you had from before. This one, maybe 885. Reason, there's a stub left. So, here we go. And we are going to, let's say, 15 or something before we call it a day. And I'm just looking at the digits, hope it goes good. 14, 15. Drag it out. And everyone needs to get blown once in a while. And now it's your turn. What I actually should have made you was one that was even smaller than the standard one you had. And the reason for that is RVS cases is 500s. Oh, it was a big cone. 500s less than Norma. So if you start screaming, can't squeeze the neck all the way down, give me a call, I give you a new one. And I think if the shoulder is too wide, you just kick it in the bench again, do a little small talk, cut it down to, let's say, this, approximately, maybe. And of course, when I shorten it, I took away my bevel. So we'll try once more. Put a slight bevel on, even more, doesn't care. This is just so you don't run if there is a little radius down the die, so you don't ride on it, so it clears the radius. And see, this little piece is left. It's stepped inside, and I know it's too short. We make you a bushing. Use it for, I don't know, two-step neck maybe? Okay, squeezed down with no expander comes out approximately 885, and that is with a 3346 or 8.5 millimeter hole. So it goes a little back. That's the one you have, and it's marked with down and 23-degree shoulder each side. So that's the one that was within here. If you for some reason want to squeeze it down to, let's say, 9, this is 908, meaning 3575 inches, point in front. 23.5 degrees is marked. If for some reason you need 8.85, 84 or 3408, this was left between something, maybe you can use it. Okay, this is 8.6 ID, and the ID behind this is it's easier to drag the expander out of the case. That's the only reason. Or you may end up not using the expander at all, then it must approximately be a little bigger. Hey you little guy, I am cone. I am 9 millimeters here, and I cone down to approximately 808 on this side. So, I don't know, it was a leftover, so I just coned it. If for some reason the smallest bushing, 850, won't get you down where you want to be, I can make you another one. Or this old RBS cases, 9362. They are 0.05 millimeters thinner, so you may need to squeeze it more down. So either way, you can press it like you have a cone neck, or you can flip it around and press it to 808. I don't know. It's just, you know, it just lays around. Why not cone it? And when you use this die, it is the resize reamer with a 9 millimeter neck, and the neck is, okay, it's here, and the neck is bored away, so it's a small section that's a little over 9 millimeter. Then this one comes into play. With a small shoulder, you can crush your case on, so you have a tight fit in the chamber, or flip it around, use the 90 degree on the other side, go all the way down approximately. But this is meant for when you have shot your cases one time in your chamber, use this one. It's not actually meant for first time pressing, but you can do. Regarding the bushings, they are not hardened, either is the die. This is, I think, tool steel, so it may be hardened if you wish to. If it's not hardened, you will scratch your cases a little bit, but this is what we work with for now.